All right, we've been talking about functions a lot lately, so we're going to go take that a little bit further today, and we're going to talk about functions on graphs. So real-world functions, what do they look like on graphs, and how do we interpret them? So I'm going to play this video. This is just a quick video. I want you to see for yourself if you can figure out what's happening between the video, or sorry, the image, the pool on the left, and the graph on the right. All right, so play that, see if you can figure out what's happening. So it looks like we have time there up there on the upper right, and time is in hours, according to our graph. So what's happening to the depth of the pool as time passes? It looks like as time is passing to 6 hours, the depth of the pool is actually getting lower. And then starting at 6 hours, the depth of the pool is rising. Okay? And so it rises until 10 hours. At 10 hours, the depth of the pool stays steady for a little while. And then it looks like the depth of the pool starts to lower again. So you notice in the lower right-hand corner of the pool, you see a leak. Right? So the pool is leaking. And at 16 hours, so I'll show you that, a picture of that graph here. So at 16 hours, right here, the depth of the pool is right about here, right? So at about 2.5 feet. So you have this slow leak, maybe not so slow. We have this leak in the pool. So as we fill it, it's still going to continue leaking. It depends on how quickly we're filling the pool. Right? So that's kind of what's happening. The pool is, the water, the depth of the pool is becoming lower. And then as time goes on, at some point, like right here, the depth of the pool is actually rising, so it's filling. And then it starts getting lower again, so that leak starts having impact again. All right, so what are some things we can gather from this graph? So first of all, remember domain and range. What is domain? Domain, if you remember from before, is typically, is always going to be our x values, and a range is always going to be our y values. Well, this time x is just called t for time, and y is called d for depth. So we're going to replace x with t this time. So what is our domain? So if you think about this, our domain, again, this is going to be t, and this is going to be d. Right, so our domain is t. It looks like our domain starts here, right? So it starts at 0, and it ends right here. So it ends at 16. So our domain goes between 0 and 16. So if you recall how to write that domain, it goes from 0 to 16. We need our inequality symbol. So the domain is going to be greater than or equal to 0, but less than or equal to 16. So that tells me between 0 and 16. So there's our domain. What about our range? So let's look for the lowest point in our depth and the highest point in our depth. Well, it looks like the lowest point is right here, and it looks like the highest point is right here. So it looks like our depth, our range, starts over here and ends here. So it looks like our depth is between 1 feet, 1 foot, and 3 feet. So I'm going to say D. In this case, our range is between 1 and 3. So greater than or equal to 1 and less than or equal to 3. So we can gather all that information from this graph, and we can tell our story. We can say that the pool begins at a depth of 2 feet and starts leaking until we hit 6 hours. So for 6 hours, that pool is, the water is leaking out of the pool, and the depth is becoming less. The depth is lowering. It looks like at 6 hours, when we start filling that pool at a faster rate. So we turn off the hose, and the depth starts to rise until we get to, it looks like 11 hours. So up to 11 hours, the depth is rising. But then again, it looks like that leak takes over, and we have a lower depth again from 11 hours down up to 16 hours. Our pool is leaking again, and we have a lower depth in that period of time. There's something else I want you to be able to tell about this graph, and that's these two terms up here with an independent variable and a dependent variable, right? Okay, so there are a couple things I want you to remember. Again, domain is typically x, right? In this case, it's t. And range is typically y, or in this case, it's z. Which one of those is independent and which one is dependent? In other words, which depends on which? Does the time or the hours depend on the depth of the pool? Or does the depth of the pool depend on how many hours have passed? So one more time. Do the hours that have passed depend on how high or low the pool is? Or does how high or low the water is in the pool depend on the time that has passed? Well, I would say what makes more sense is that the depth of the pool depends on the time. So depth would be our dependent variable, because our depth depends on the time. So if depth is our dependent variable, then our independent variable must be time. Right? So again, depth depends on time. So that's independent and dependent variable. So when you're going through one of these, you're trying to figure out which one is which. Ask yourself what depends on what and what makes more sense. Very often, or most times, time is going to be independent. Now that's not always true, but most times for what we're going to be doing, time is going to be independent variable. There's another thing about independent and dependent variables. X is always going to represent your independent variable when you have x and y. X is always going to be independent, and y is always going to be dependent. So if we think about this, we have now three ways to describe x and y. So what are those three ways to describe x and y? Well, x is just x. X is also our independent variable. And x is also, if you think back to that first slide, x is also the domain. So these three things, these three vocab words here are interchangeable, or these three expressions are interchangeable. So we have x, independent variable, and domain. Those all mean the same thing. Although what about y? So we have y. Well, if it's not the independent variable, it's the dependent variable. And if it's not the domain, it's also the range. These are the three phrases to remember for y. So x, independent variable, domain, all mean the same thing. Y, dependent variable, and range also all mean the same thing. So these terms are interchangeable. All right, so last thing. These are also two words you're going to want to remember. You could have an increasing function or a decreasing function. Well, these are pretty self-explanatory if you look at a graph of a function. Right? So if you think about our graph from before, our depth kind of went like this, lowered, and then it rose and stayed steady and lowered again. Well, there are points on this that are increasing and there are points that are decreasing, right? So here's our independent variable, here's the dependent variable. So which part of this would represent an increasing function? Well, from here to here would represent an increasing function, right? So it's rising from left to right. Right? So there's an increasing function. And if you think back to slope, that would represent from lower left to upper right, that would represent a positive slope. So positive slope represents an increasing function. So the other parts of this, so from here to here, so now we're going down to the right, this would represent a decreasing function. So that's decreasing, this is increasing, and again this portion over here would represent another decreasing function. One more quick example. Is this a decreasing function? Right here, is this a decreasing function or an increasing function? It's not linear, right? It doesn't just follow a straight line. That would be linear, but this isn't linear, it's curved. It's not a linear function, so it's a non-linear, right? And it's not linear, but it does still just represent an increasing function. Even though it's got these curves in it, it's still always going up towards the right. It's still always increasing at a quicker rate right here. It starts increasing at a slower rate here, and then it picks up and starts increasing at a faster rate here. So even though it's curved, that would still completely represent an increasing function.